next example on extreme values or maximum and minimum values. So question is what? Discuss the maximum and minimum of the function fxy is equal to this x cube plus y cube minus 12x minus 3y plus 5. Or the question is what? Discuss the extreme values of the function or find the maximum and minimum value of the function. Or the question is what? Find extreme value of the function. Or question is another question format is what? Find the local maxima and local minima of the function. So the given function is what? The answer of all questions are is same. That is the, this is the answer. That is consider this as fxy function fxy x cube minus x cube plus y cube minus 12x minus 3y plus 5. Then find first and second order partial derivative with respect to x and y. So fx partial derivative with respect to x, x cube derivative is 3x square, y cube derivative is 0, minus 12x minus 12, minus 3y derivative 0, and 5 derivative is 0 with respect to x. Then with respect to y, 3y square minus 3. And then fxx means the derivative of fx with respect to x is what? 6x. fxy means the derivative of fx with respect to y is 0 because it is a pure function of x. Then fyy means the derivative of fy with respect to y is 6y. Then stationary points. How we can find stationary points or critical points? Consider the equation fx is equal to 0 and fy is equal to 0. So this is fx is equal to 0, fy is equal to 0. And then by solving these equation 1 and 2 simultaneously or independently, find the values of x and y, and that gives the critical points or stationary points. So from either independently or by use simultaneously, that is by adding these two equations, subtracting, by multiplying, dividing, or find the value of x from one equation and substitute in another equation, or substitute the value of find the value of x or y from the second equation and substitute in first equation. So this is the procedure. So here we have the value of x from equation 1 and value of y from equation 2. So these are solvable independently. No need to solve these simultaneously. That is from equation 1, 3x square is 12, x square is 12 by 3, that is x square is 4, therefore x is what? Plus minus 2. And no need to write substitute this value in equation number 2. We have the value of y also from equation number 2 independently. 3y square is equal to 3y square is 1, y is plus minus 1. And that's why the critical points of stationary points are what? All combinations of these plus minus 2 and plus minus 1, all combinations. Because we have the values of x and y independently. And what are the combination? Both are plus, both are minus, one is plus, other is minus. That is, these are the critical points. 2, 2, then minus 2, 1, then minus 2, minus 1, and 2, minus 1. These are the four combinations of these values of x and y. So the nature of the function, that is, we have to determine the nature of the function. That is, at the point 2, 1, the function is maximum or minimum. Similarly, at the point minus 2 plus 1, minus 2 minus 1, and 2 minus. So there are four parts. So first part is what? The nature of the function at the point 2, 1. So find capital A, that is fxx at that value, at value of fxx at 2, 1. That is, substitute x as 2 and y as 1 in fxx. So this is 6x, 6 into 1, that is 12. Then b, the b means what? fxy, the value of fxy at this point 2, 1 is 0. And then value of fyy at 2, 1. That is, substitute x as 2, y as 1. So here is f, this is 6x. So x is 2, y is 1. So right here, fxx is what? 12 into 2. Right here, correction is here. So write the value of fxx. fxx is 6x. So 6 into 2. That is 12 into 2. 6 into 2. The answer is what? 6 into 2. Right here, 6 into 2. That is 12. Answer is correct. But here write 6 into 2. And then fyy is 6 into 1. Y is 1. So we have delta is AC minus B square. 12 into 6 minus 0 square. That is 72, and the value of delta is greater than 0. So as delta is greater than 0, and what is A? A is also greater than 0, and so the function fxy has local minimum value at 2, 1. Okay, fxy right here, fxy has a local minimum value at the point 2 1. That is, the function is minimum at the point 2 1, and the minimum value of the function is what? F of xy is what? F of 2 1. That is, substitute in the formula fxy as x is 2 and y is 1. So we have 2 cube plus 1 cube and all these values, and so we have minus 13 answer, the minimum value of the function. Then no need to find minimum value again. If the suppose the function is minimum at the second point, suppose at this point, that minus 2 plus 1, then no need to find the minimum value, because if you find the minimum value at that point, then we have the answer, same answer. So once if we find minimum value or maximum value at some point, then no need to find the minimum value or maximum value may attain for more than 1 points, but the value minimum value is unique, maximum value is unique. Okay, that is, once we get minimum value of the function as minus 13, then if the function is minimum at some point, another point, then we, if we find the value minimum value of that function at that point, then we have the same answer, minus 13. So minimum value or maximum value may be attained at more than 1 points, but the minimum value and maximum value are unique. Then the nature of the function number 2 at point minus 2 1. Then find capital A, that is fxx at minus 2 1. Then capital B, capital C, that is fyy at minus 2 1. And we have the delta as minus 72 is less than 0, and therefore minus 2 1 is saddle point. That is, write this minus 2 1 as saddle point, or write the sentence that the function is neither maximum nor minimum at minus 2 1. Okay. Then third point is minus 2 minus 1. Again find capital A, capital B, capital C, delta, and we have the delta is greater than 0, and at this point A is less than 0. A is less than 0, right? Correction is here. A is less than 0. Sorry, what is A? A is 6 into minus 2. X is minus 2. 6 into minus 2. 6 into fxx is what? Fxx is what? 6x. So 6 into minus 2 is minus 12, and therefore A is less than 0. So right, correction is here. Delta is greater than 0, and A is third point. This is second point. This is third point. Minus 2 minus 1. Okay. So delta is 36 greater than 0, and A is less than 0 right here. A is less than 0 because A is minus 12, and therefore the function is maximum at point minus 2 1. Or fxy has a local maximum value at minus 2 minus 1. So here is right maximum instead of this minimum, because delta is greater than 0 and A is less than 0. So correction is here. And the maximum value of the function is what? Right here, the maximum value of the function fxy is equal to f of minus 2 minus 1. That is, substitute x as minus 2 and y as minus 1, and we have the answer 41. Check this answer also. Then lastly, at the point 2 minus 1, the nature of the function at the point, critical point, last point is minus 2, 2 minus 1. 2 minus 1 is the last point. Then find again capital A, that is fxx at that point 2 minus 1. Then capital B, capital C, and then write AC. Here what we have, the answer delta is minus 72, that is less than 0, and therefore 2 minus 1 is also saddle point. That is, the function is neither maximum nor minimum. So the function is minimum at the point 2 1 and maximum at the point minus 2 minus 1, and at these 2 points the function is neither maximum nor minimum. That is, the 2 points are saddle points. So correction is at this place. So correct this problem, answer of this problem, while writing in your notebook. Find extreme values of the function fxy is equal to 3x square y minus 1, this function y square in bracket. So simplify first this function in because we have to find its partial derivative with respect to x and y. So in order to find partial derivative, simplify this function as this. That is we have this one, and then its derivative with respect to x, 6xy, then 6x minus 6x, derivative is 0. Here write y into y square into y as y cube. Right here y cube. Then derivative with respect to y, 3x square. The derivative is 0, and this is y cube. 3y square is derivative minus 6y. And then fxx means the derivative of fx with respect to x, 6y. 6xy derivative is 6y minus 6, and the derivative fxy. Fxy means the derivative of fx with respect to y. Fx with respect to y. So 6x is the answer. Minus 6x derivative 0. F of y means derivative of fy with respect to y. Derivative of this quantity is 0, and 6y minus 6. Then for stationary points, consider the equation fx is equal to 0 and fy is equal to 0. That is, this is equal to 0 and this is equal to 0. These are the equation number 1 and 2. Solving these equations 1 and 2. So from equation 1 we have x into y minus x dividing by 6. We have this. Then take x as common, y minus 1. Then x is 0 or y minus 1 is 0 means y is 1. So if x is 0, then second equation gives 3y square minus 6y is equal to 0. That is, we have this, y, take y as common, y is 0 and y is 2. So if x is 0, then y is 0 or y is 2. And so we have two critical points, 0, 0 and 0, 2. Because if x is 0, then y is also y is 0 as well as 2. So 0, 0 and 0, 2. These are the two, we have the two critical points after this discussion. Then substitute y as 1 in equation number 2 or in equation number 1. So in equation 2, if we substitute y is equal to 1, then we have, don't substitute in 1 because from 1 we have these values. So substitute all this x is equal to 0 and y is equal to 1 in second. So y is equal to 1 in second, we get this 3x square plus 3 minus 6, that is 3x square is equal to 3, x square is equal to 1, whereas x is equal to plus minus 1, and therefore y is 1, then x is 1 and minus 1. Therefore the critical points are 1, 1 and 1 minus 1. So in all we have 4 critical points. The critical points are what? 0, 0, 0, 2, and then 1, 1. X is 1, y is 1, and x is minus 1, y is plus 1. Okay, so we have these critical points. X is, y is 1, then x is plus minus 1. So we have two critical points, 1, 1 and minus 1, 1. Don't try to 1 minus 1. 1 minus 1 is not the critical points or stationary points. Then nature of the function. So at 0, 0, then at 0, 2, number 1 at 0, 0. Find capital A, capital B, capital C. Capital A is what? fxx at 0, 0. So this is fxx. fxx is this formula. 6y minus 6, substitute x is equal to 0 and y is equal to 0 in fxx, fxy at 0, 0, fy at 0, 0, these values. Then delta is AC minus B square, and is minus 36, not 12, minus 12. 6 into minus 6 is minus 36, right here. Minus 36 is less than 0, and therefore 0, 0 is saddle point. If delta is less than 0, then the point is saddle point. Then at 0, 2, find capital A, capital B, capital C. It is 36, not 12. 6 into 6 is 12, is not 12, is 36. And delta is greater than 0. And what is about A? A is also greater than 0. And therefore, as delta is greater than 0, A is greater than 0. And therefore, the function has local minimum value at 0, 2. And the minimum value of the function is what? Of the function fxy is equal to f of 0, 2. Find f of 0, 2. We have the answer minus 3. Then at point 1, 1, find capital A, capital B, capital C, delta. We have again delta is greater than 0, and therefore the function, and A is equal to 0. A is equal to 0. AC 0 minus 36. It is not plus 36. 0 into 0 minus 6 square. Minus 6 square is 36. So answer is minus 36. So right correction is here. Minus 36 is less than 0, and therefore the point 1, 1 is a saddle point. Then at minus 1, 1, 0, find capital A, capital B, capital C, delta. Delta is what? AC minus 12 into 0 minus B. B is actually minus 6, but minus 6 square is plus 36. So here write minus 36. Answer is minus 36. AC minus 12 into 0 is 0 minus 6 square. Minus 6 square is minus 36 answer. And therefore minus 1, 0 is also the saddle point. So at the value at the minus 1, 1, and capital A minus 1 1 minus 1 1. So what are the values of A? Minus 1 1 minus 1 1 minus 1 1. So fxx is 0. Yes, correct. Then at the point minus 1 1, fxy is 6 into minus 1 is minus 6 at this minus 6, correct answer. And then at minus 1 1, the value of fyy. So substitute x minus 1 1 is 0. Okay, this answer is, these are answers are correct. And so right here minus 36 less than 0, and therefore this minus 1 1 is a saddle point. Okay, so actually these are the problems for homework. So there is some correction. Find extreme values of the function, this e raised to 2x cos 1. Then find extreme values. So find fx first order partial derivative as well as second order partial derivative, fxx, fxy, fyy. So what is the fx? Is e raised to 2x. Derivative is what? 2 e raised to 2x, because e raised to 2x derivative is e raised to 2x into derivative of 2x is 2. Cos y is constant, and fy is what? E raised to 2x constant now, and the derivative of cos y is minus sin y. Then consider equation fx is equal to 0 and fy is equal to this is equal to 0. So we have this is equal to 0, means this 2 is not equal to 0 and e raised to 2x is always not equal to 0. So cos y is 0, and cos y is 0 means y is cos inverse 0. This 2 is not equal to 0, e raised to 2x is not equal to 0. For any value of x, if x is 0, then e raised to 0 is also 1. So this is non-zero quantity, e raised to 2x, and therefore cos y is 0, and therefore y is cos inverse 0, and y is pi by 2. Therefore cos inverse 0 is what? Pi by 2. Or we have the another answer 3 by pi by 2. The answer is what? Actually 2n plus 1 pi by 2. 2n plus 1. That is, if we substitute n as 0, n as 1, then 3 pi by 2 answer. N as 0, then pi by 2, 3 pi by 2. Okay, so we have the these answers, and from second, substitute, if we substitute x is y is equal to pi by 2 in second, then what we have? E raised to minus 2x sine pi by 2, sine 90. Sine 90 is 1. So e raised to minus 2x, e raised to minus 2x sine pi by 2 is equal to 0, is equal to 0. But what is e raised to minus 2x is not equal to 0. Sine pi by 2 is not equal to 0, and therefore we have therefore we does not have the value of x from this, and therefore fxy has no critical point. No one is critical point. That is, we cannot find the value of, if we substitute y as pi by 2, then we have e raised to minus e raised to 2x sine pi by 2. Sine pi by 2 is what? Is 1. So e raised to minus 2x is 0. Then what is what is x? So we cannot find x, because e raised to 2x is always not equal to 0. E raised to x, e raised to theta is always not equal to 0 for all theta, and therefore we does not have the value of x, and therefore this function has no critical point. Find stationary point of this function. So I can fxy, find fxy, then consider the equation subtracting these two equations. We have this cos x, therefore x is equal to y, and if x is equal to y, in substituting equation second, then we have this cos x plus cos 2x is equal to cos 2x is minus cos x, and cos pi minus x, cos minus value of cos minus cos x is, so I cancel the cos x, so 2x is equal to pi minus x, 3x is equal to pi, x is equal to pi by 3, and if you substitute x is equal to pi by 3, x and y both are same, so y is also pi by 3, and therefore stationary point or critical point is pi by 3, pi by 3. And if you had to find its nature of the function, then find second order derivative and find the values at pi by 3, pi by 3 of capital A, capital B, capital C, delta, and then we find the nature of the function at that point. That is, the function is either maximum or minimum or a saddle point. Next problem, a rectangular box open at the top is to have a volume 32 meter cube m cube. What was with the dimension so that total surface area is minimum? So we had to prepare a box, open box. Open box means what? The top is open at the top, means there is no top for the box. So there are 5 surfaces to for the box, and we had to prepare it as its value. It is value, not value. To have a value here, right? The word volume, not value. Volume 32 meter cube. So we have to prepare the box such that its volume is 32 meter cube. Okay, and so what is the dimensions we keep this surface area minimum. Okay, so condition is what? Surface area. We have to prepare the box in such a way that the surface area is minimum. So suppose the dimension of the box is what? Suppose x is length, y is breadth, and z is height. And then volume of the box is what? Length into breadth into height, x, y, z, and it is given 32. So z is what? 32 divided by x into y. So first express this z in terms of x and y. And surface area also, there are 5 surfaces for this box. So find the area of each surface and add all these 5 surfaces. So this front surface has the value x into z. What is the not value? Area. What is the area of this surface? Length into breadth is its area, x into z. Then its back surface is of the same dimension, so it is again plus hz. Then area of this surface is what? Z into y, and area of the opposite surface is again plus zy, z plus zy or yz plus yz 2 times. And the area of the bottom surface is what? X into y. There is no tops for the surface, so plus x into y. And therefore we have 2xz plus 2zy plus xy. Take 2z as common from this and substitute z as 32 divided by x into y. And simplify this function. We have this 64 by y, 64 by x plus xy. Okay, after simplification, here is the simplification. And denote this function as fxy. That is, surface area is denoted by now the function fxy. And now we have to remains fxy minimum. Okay, so the same procedure that find the first order derivative with respect to x and y, and then second order derivatives and the values of capital A, capital B, capital C. We will discuss this problem in the next lecture.